All right, so here is chapter 11. I think this is the same chapter 11 you have because I have like 2 different versions of it. I do have the mic on. See the little audio thingy? See, testing 1, 2, 3. It gets real loud. GeoGebra man, that's for Cole. All right, let's do this. Here we go. Find the area of each parallelogram. So, this is the area stuff, and then the next chapter is all the volume stuff. So the area stuff seemed easy, doesn't it, compared to the volume? Yeah, I'm going to give you a formula sheet. Okay. I'm going to give you a formula sheet. Yeah. Yeah, I'm going to give it to you. I'm going to give it to you during the final, so you have it in front of you. Okay. All right. So here we go. Find the area. How do you find the area of a parallelogram without the formula sheet? Yeah, it's just the base times the height. What is true about the base and the height? What do we know about the base and the height? It has to be what? No. They don't equal. You can't say they equal the area. But what's the relationship between the base and the height? They always have to be what to each other? Perpendicular to each other. In fact, Miss McDonald teaches one of the periods where I have a planning period in my room, and she was teaching this the other day to them. They were doing area, and she said the base and the height have to be perpendicular. They have to be a right angle. And she teaches a bunch of different things. So I was like, that's what I teach. I was so excited. Okay. No, not really. Inside I did. I didn't say it out loud. All right, so it's the base and the height. So the deal is, look, let's say we call the base 20. Is the height 10? Do we go 20 times 10, 200? Is that the area? No, what's the height of this thing? It's got to be perpendicular, correct? So this right here, let's make that a little bit bigger. There we go. That's better. Okay, this right here is the height. Problem is, they don't tell us the height. We got to figure out the height. But yeah, so you got to do several things on this problem. The area is the easiest part of it. You have to think about how to find this height right here. Well, they give you the hypotenuse. It's 60 degrees, so it's 30, 60, 90. That's what I would do. I wouldn't do trig. I would do 30, 60, 90. So you know the hypotenuse. Can you go directly from the hypotenuse to the longer side? No, but you can do the short side. What's the short side? 5, right? Because the short side's half the hypotenuse. And now once you find the short side, how do you find the height? Add it. Right, multiply it by the square root of 3. So it's 5 square root of 3. So did you have to go through any trig to do that? No. In fact, if you went through trig, you would have had an approximation, wouldn't you? All right, this is what? Exact. Okay, now it does say round, but that's okay. We'll put it into a calculator anyway, so it really won't make much difference. But at least that was easy to do. It was quick, right? As long as you know about 30, 60, 90. And you're supposed to, because chapter 8 is on the final, and we talked about that already. Brad?
On the formula sheet, are you going to give us like a 60, 30 right triangle?
Don't know. I would tell you this. Don't completely rely on the formula sheet because you don't know what's going to be on there. I'm not going to sit here and tell you everything's going to be on the formula sheet. Okay, there will be some things on there that might be helpful, but you should still know this stuff. All right? So don't take any chances. I would know this stuff. Don't just say, I don't have to study any of these things because it's on the formula sheet. Study them. Study, study, study. Okay, that's what I'm trying to get you to do. All right, so now how do you find the area of this thing? It's the base times the height. So what is the base? 20. What's the height? 5 square root of 3. So really, if you wanted it, now this does say round it to the nearest tenth, so it's perfectly fine to put it into a calculator. But let's say we wanted to get an exact answer just to be fun here. All right, what would we do? 20 times 5 is what? 100 square root of 3. So you could keep your answer like that without even touching a calculator. Wouldn't that be nice? Or you could chuck it into a calculator if you wanted to, get a decimal, whatever that is. All right, what about this one right here? Same deal, isn't it? Kind of the same deal. They don't tell you the height. They do tell you the base, which is 12. And you got to figure out this blue thing right there. We'll make it blue. 45. Yeah, it's 45, 45, 90. They tell you a leg, so it's even easier than this one. It's what? The same thing. It's 6.5. Very good. So what's all the math you have to do to find the area? Yep, 12 times 6.5. You can do that yourself. I'm just going to show you how to do the steps. As far as the actual math and arithmetic, I'll leave that up to you, just to speed things along. Is that okay?
Yeah.
All right, so there you go. So that's all empty space right there. Okay. 78, is that what it is? Okay. Look at this one right here. Now, this time they tell you the area. It says if the area. So they tell you the area, and they ask you to find x, or the what of this parallelogram? The height, right. So we're trying to find the height. So remember, area equals the base times the height. They tell us the area, which is 570. They also tell us what? What do they tell you? The base, right, AD, that's 19, okay? So they tell you the base, and what do they ask for? The height. And we'll just call it h. Is that all right, since I have it right there? H and x would be the same thing. So what's my only math I have to do here? Divide by 19, and whatever that is, that's the height. And that's what they ask for, isn't it? Because x is the height. They just ask for the height. Because they already give you the area, right? You're not finding the area because they already give it to you. What is it? 30 even? I guess it is, isn't it? 19 goes into that 3 times. Yep. So 30. All right. That was nice and easy. Area of a trapezoid. How do we find the area of a trapezoid? Yeah, remember, it starts with a T. What other thing that you work with a lot starts with a T? Triangle. What's the area of a triangle? Base times height divided by 2. Trapezoid is pretty close to a triangle, even though it's got 4 sides. The area is kind of close. So what's the area of a trapezoid? Well, still divided by 2, right? It's like base times height divided by 2. But how many bases do we have? We have 2 bases. We got 1 here and we got 1 here. So it's the 2 bases times the height, correct? If you have to sit there and say, okay, I'm going to go through all these formulas. The area is B1 plus B2 times H over 2. Do you need to do that? No. Think of this. Think of my little tricks. The trapezoid starts with T, so does triangle. When I think of it, I think the area of a triangle, I know that. That's easy. Okay, I should have that memorized, long time ago. Base times height divided by 2. But a trapezoid is different than a triangle. It's got 2 bases. So I just add the 2 bases together, multiplied by the height divided by 2. Isn't that a nice way to remember it? I think so. Well, let's keep going. Problem is, we know the 2 bases. We know the B1 and the B2. What's the one thing we don't know? The height, which is 4. How'd you do that without using a calculator? It's a 3, 4, 5 triangle, right? Because there's a right angle. One of the bases is 3. Or one of the legs is 3, I should say. The hypotenuse is 5. That has to be 4. See? We hardly had to use a calculator at all on this so far, have we? So you can plug the stuff in, right? So it's just 32. I'll just read it off. 32 plus 11, right, which is what? 43 times the height, which is 4. Divide that by 2. It's 86 because I know that 4 divided by 2 is 2. So it's 86. Good. If I go a little fast, you can always go back to the video and watch it. That's the nice thing about having the videos. So if I lost you, you can always go back. Now, what's this 2.4? That's this thing. What do we call that of a kite? We call that, it's not the diameter. Diagonal, right. Starts with DI, A, but it's diagonal. All right. And what do we know about the area of a kite? Do you remember that?
B1 plus D2.
And there's something else in there? It's 1/2. Did you say 1/2? Okay, I didn't hear it. I was listening for it. Okay, so it's 1/2 D1, D2. Now this is straightforward, isn't it? All right, there's nothing tricky about this at all. They give you one. Now they put it down here, but that 6 would be the same as this diagonal. Would you agree? And this 2.4 would be the same as this. So what do? Just multiply them together, take half of it. Okay, or you could do this. You take half of 6, right, which is 3, and then 3 times that. It doesn't matter. And then we're good. What's your answer? 7.2? Okay. Anybody comparing this to the test that they took the first time?
Yeah, it's so easy.
Do you have your original? Do you have your original test? Okay. Just make sure we're getting the same answers that I gave on the original test. I don't have them in front of me, so I'll use you to see if we got it right or not. All right, area of a triangle. All right, we already talked about area of a triangle. What's the area of a triangle? Base times height divided by 2. Or you could put 1/2 the base times the height. It's the same thing. So let's see. What do we have here? Well, we have they don't tell you the whole base. See how they stick that 15, like, not right in the center of it? All right, so this is the 15. So what is the whole base? Right, so the whole base is 30. Actually, you could just use the 15. Forget the 1/2, right? So aren't you going to take the base divided by 2 anyway?
Yeah.
Right, can you see that? All right. Some people are so locked into these formulas they can't see beyond it, all right? Because I'm looking at it like, oh, it's the base times height divided by 2. Well, I've already divided by 2 to get to 15, right? So it's just 15 times 25, right? Would you agree? Okay. Or you could go 30 times 25 and then divide it by 2, but that'd be the same thing as 15 times 25. What's that answer? I can't do that in my head. 15 times 25. What's that? Quick. 375? Okay. Is that, did you check your old test? No, don't. It's, did you, is that 15 times 25?
Yeah.
Okay, that's right. So you wouldn't take that and divide it by 2, would you? You would take 30 times 15 and divide that by 2. Yeah, because that would be 750, right? Because 3 times 25 is 75, right? 3/4. Okay, and so that'd be 750. 750 divided by 2 is 375. Good. All right, let's do this. Rhombus. What's a rhombus? No. All 4 sides are equal to each other. Okay. So what are we doing? Finding the area. So what's the area of a rhombus? Now, well, it's the same as a kite. Yeah. It's the same as a kite. All right. And look, they tell you both of them. So you use 9 times 7, what? 63 divided by 2 is, what's that? 31.5. Okay. Alrighty. Wow, this is so easy. Oh, now we're getting to the good stuff, aren't we? Well, I don't know if you consider the good stuff or not, but I do. What? Don't say that. It's sacrilege.
Sacrilegious.
All right. So let's find the area of a square with a apothem of 3 inches rounded to the nearest tenth. I got to find some room on here to draw this. So what I would draw, let's do it down here. Is that all right? And what is the apothem? The apothem is from the center of this thing right there, perpendicular to a side, right? So that would be, right, because look, that's not straight down, is it? It's perpendicular, okay? So they give you the apothem, right? Find the area of the square with the apothem of 3, so that's 3. You can actually, since this is a square, you don't even have to go through that whole apothem thing. This is actually a little easier. It says find the area of this thing. Look, if from here to here, and it's a square, right? And it's the center. If that's 3, what's the whole length of this side? It's 6. And if it's a square, what's the length of that? Right, that's 6. And how do you find the area of it? Just 6 times 6 is 36. Because this is from the center to here, and then so from here to here is 3, so the whole thing is 6. All the sides, since it's a square, all the sides are equal, right? Since it's a square. So that was kind of easy, wasn't it? Yeah. What made it easy? Yeah, I'm looking for something else. Could you have just done that in your head? How did this help you? Drawing the picture. That's what I was trying to get at. Okay, draw the picture. Draw the picture. Look at this one. Find the area of a regular hexagon with a side length of 15. Now you could try to draw a regular hexagon if you wanted to. That's all you really need to draw. Okay? Because look, this is what I would do. Regular hexagon. I would draw it. I would just draw a little bit of it. Would you agree? It looks kind of something like that.
Yeah.
And the apothem's probably going to be in here somewhere like this. Would you agree?
Yeah.
We'll drop this thing down like that. Perpendicular. I haven't put any numbers in, but I do know some stuff here, don't I? I know this angle. How can you figure out that angle? Well, let's see. No, I don't even care about that angle, do I? What am I going to do? Do you remember this? We're going to go from here to there. This is the easiest part. The easier way to do it. So we can find that angle right there. Watch, I'm going to put another one just to kind of... I'm not going to go through this whole thing. You can watch the video if you want. But watch, this whole angle. How can I find that whole angle right there? Not just this little part, but from here all the way to here. I went to this corner and this corner. How many of those triangles are there going to be if it's a 6-sided figure? 6 triangles. Okay, so this angle is 1/6 of the whole entire way around. whole entire round is 360, right? So 360 divided, don't use a calculator, 360 divided by 6 is what? 60. But this is really what I want. I want this angle inside the triangle. So the whole big angle is 60. What's the angle inside of here? This is 30. So guess what we have? We have a 30, 60, 90 triangle. All that just knowing that I had a regular hexagon. Didn't even look at the numbers yet, did I? Okay, I went through all that just knowing I had a regular hexagon. Let's stick some numbers in. It says the hexagon has a side length of 15. That means from here to here is 15. But that's not really what I'm going to use, though, is it? What am I going to use? I'm going to use half of it. That's right. I'm going to use just this part right here because I'm looking at this triangle, right? So I want to use that part right there. Tell you what, let's get rid of this 15. Oh, my goodness. There it goes. I forgot to do this. There we go. All right, so let's make this 7.5. Let's make this a little bigger so you can see it. There we go. And what are we trying to find? I don't know. What's it say? Find the area. Find the area of it. Okay, good. So we should know how to find the area of a regular hexagon. You remember what that formula is? It's another 1/2 perimeter times the apothem. Very good. All right. Well, we can find the perimeter pretty easy. Because remember, one of the sides is 15, correct? So how do I find the perimeter? 15 times 6, which is what? Is that 90?
90, yeah.
Okay. All right. So that we know, watch, 1/2 of 90, which is 45, times the apothem. So we got to find the apothem, don't we? Which is this. Oh, it's not 15. It's this one right here. That's the apothem. It's a 30, 60, 90. You don't have to do trig. You can do what you know about 30, 60, 90s. You know the short side. How do you find the long side? Times the square root of 3. So 7.5 times the square root of 3. See how nice that is? All right. So you just stick that in here. 7.5 times the square root of 3. Stick all that into your calculator, and you should have the area of that hexagon. So it took a little thought, right? We drew the thing out. We didn't have to draw all 6 sides, did we? We just drew the important stuff. Here's what you really want to do. You want to draw to this vertex and draw from the center to this vertex. You got the big angle. You can figure that out. 360 divided by how many angles you have. Should be 6 of them because there's 6 sides. Take half of that. That's 30. You got this triangle, right? You want to find the perimeter. You already know the length of the sides, 15. So it's 15 times 6 because there's 6 sides. 90 degrees, or not 90 degrees, but just 90. And then there you go. What is it? 584.6. Is that what you said? Okay, I'll take your word for it. And there we go. How's that? Not too bad, is it? Yeah, it's not that bad.
It all seems so much easier when you get the final.
Yeah, because you've seen it before. A 0.
66.
All right, let's keep going. We got to keep going. We're only halfway through. So Jamie shades in a piece of circle defined by this a central angle of 12 degrees. Okay, they don't put it in here. We'll have to write it in there. Find the area of the shaded sector. Oh, this is easy. Watch this. Let's go with this color. So this is 12 degrees. Central angle is 12 degrees. And we want to find the area of just the shaded part. Okay? So we just want to find the area of this shaded part right here. Now, how do you find the area of a whole entire circle? Pi r squared. But this is not an entire circle. It's how much of a whole circle? It's 12 over 360, right? It's 12 degrees out of 360 degrees. We're not finding the whole circle. That'd be 360 over 360, wouldn't it? This is 12 over 360, what? Pi r squared. The r, they tell you, it's 4.3, and then squared. So this is what you would chuck into your calculator. And that's all there is to that. So it's just knowing 12 over 360. That's all you had to know, isn't it? Yeah, and 1.9, is that what you said? Okie doke. There we go. All right, let's keep going. Find the area of this. Well, yeah, it's easy. Just find the area of the two together, correct?
6 times 6 is 36. Yeah. So I can be.
How do you know it's 6? Well, because it's all four of these sides are the same, right? So if that's 6, so what's this? It's a square, isn't it? So that's 36. Now, if from here to here is 6, what's this little bit here? That's 2. And what's this up and down one? That's 6. So that's 12, right? But it's a triangle, so it's base times height divided by 2. So this would be 6. So it's 36 plus 6, and what's that? 42. Easy. It is, isn't it?
It is. Once you go over it after we took a test.
See, I always get yelled at in my math classes because I always say that things are easy. Like, Mr. Hamrick, you teach this. It's easy. But after you know how to do it, it is kind of easy, isn't it? Would you agree? All right, what about this one right here? Well, you got this rectangle and you got this half circle, this semicircle. Let's do the rectangle first. Is it 6.6 times 14.3? No. It's from here to here. That's not 14.3.
You have to minus it by 6.6.
That's right. You got to minus it by 6. See that part right there? 6.6. Okay. See that part right there is 6.6. Would you agree? So from here to here is going to be 14.3 minus 6.6, which is what?
Would it be 3.3 because it's the radius?
Of course it would. That's exactly what I said. My pen just wrote it down wrong. That's right, because look, this is a radius that goes around. See this thing from here to here? That's a radius. So if I went from here all the way up to there, that's 6.6. But from here to here is what? 3.3. And so this would be 3.3. Got it? Okay, because if that swung around, it would swing around to here, wouldn't it? Okay, now, what's that? 11, just 11, right? Yep, so this right here is 11, and 11 times 6.6 is, don't know, I should be able to do it in my head, 72.6. Okay, so that's the rectangle. And then, how do you do this? This is a half circle, so it's going to be pi r squared, what? Over 2, right. So the radius, what's the radius? 3.3 squared times pi divided by 2. No idea what that is. 17.1. All right, then what do I do with that 72.6 and the 17.1? Add them together, and you get what? 89.7. 89.7. Anybody checking the answers to the original test? Anybody have it out at all? Does anybody have the original test? Let's make this smaller so I can see the whole thing. All right, let's keep going. Watch this. Find the area of a rhombus with a perimeter of 100 meters and a diagonal of 48 meters. Well, what if you have no idea what to even do on this? I would draw the thing out, wouldn't you? I'm not going to draw this very accurately. I mean, I'm going to try, but I doubt it's going to be.
It says you wrote 106.8 for 12.
I did?
Yeah.
Is it typed in there, or I made you? I change it. What's that? Oh, for the answer to that other one? Well, what would we do? For this one? For which one? For 12?
Yeah.
Or which one?
You got it wrong though, remember? No, but he wrote
I got it wrong?
Yeah, you graded it wrong. Oh yeah, it wasn't.
And then I changed it?
That wasn't it. So it probably is.
So it probably is what we said it was? Okay, good. All right. Where are we now? Yeah, I guess we'll find out. I can't remember. All right, so this is a rhombus. Pretend it's a rhombus. It doesn't really look like one, but it's close. All right, it's a perimeter of 100 meters. Now, what is that going to tell you about the lengths of the sides? If the perimeter is 100, divide by 4, so so each side would be 25, correct? And the diagonal is 48. So that right there is 48. And we are trying to find what? The area, is that correct? All right. We're trying to find the area of this thing. Do we want to find the other diagonal? Because we could do the other diagonal. Couldn't we go 1/2 d1 times d2? Or you could just go base times height. You could find this bit right here. What's the best way to do it? Did anybody get this right?
I think there was one person the whole class
That got this one?
What, 14?
No, I got this wrong.
This one was hard.
I did the wrong problem.
Let me think. There's two ways to approach this. I'm just trying to think of the easiest one. Let's do it like this. That would be the height, correct?
Sure.
So is there any way to find that height? Probably not. So let's not go that way. Let's do the diagonal thing that I was going to do before. Who said you're not allowed to sit and think about it for a minute? Okay, now again, I didn't really draw this very accurately, but this is supposed to be what? A right angle. Because it's a rhombus, right? The diagonals are perpendicular to each other on a rhombus, and the diagonals are bisected. So if this whole thing, okay, watch this. I got it now. If this whole thing is 48, let's get rid of that 48, just kind of in the way. We'll remember it though. So that's 48. The diagonals bisect each other. What's that little bit right there? 24. Now look at this. This is a special right triangle. It says 7, 24, 25. You could do Pythagorean theorem if you really wanted to, but that's 7. So what's this other part? That's 7, and that's 24. So what are my two diagonals then? 48 and what? And 14. So what's my formula for area of a rhombus? It's 1/2 d1 d2, right? So 48. Why is that so far away? I don't know. That doesn't matter. 48 times what? 14. Put little dots right there. That should give you your answer. So half of 48 is what? 24 times 14, or half of 14 is 7 times 48. 336? Okay. Is that what I wrote down for the answer?
Yes.
Good. So I am back to being GeoGebra man. What are you talking about? I know. Every superhero has their detractors. So you know. All right, look at this one. The area of a rhombus. Listen now. The area of a rhombus is 49. Did we just do that one? No, we did that one. Right. The area of a rhombus is 49 if one diagonal is twice as long as the other one. Okay, so watch. If one diagonal, we'll call it D1, is twice as big as... How do I do that? So we'll call one diagonal D1. Let's just do it like this. We'll call one diagonal D1, and what we'll call the other diagonal? No, because the one diagonal is twice as big. 2D1. You see that? Does that make sense? Do you see that? So if one diagonal we'll call, let's up here, we don't have much time. If you call one of the diagonals D1, you'll call the other one 2D1. Don't call it D2 because they give you the relationship. One is twice as big as the other one, right? This is twice as big as this. Agreed? And it tells you the area. They tell you the area is 49, and you got to find the length of the two diagonals. Let's actually find out what D1 is. Well, let's put it into our formula. Area is 1/2 D1 times D2, but what's my D2? Twice D1. Now look at this. They tell you the area, correct? It's 49. But watch what happens right here. What happens to this 1/2 and this 2? Cancel each other out. And what's this number right here? This is 49 equals D1 times D1 is what? No. Times. D times D.
D1 squared.
It's D squared. Square root, and D is 7. So if one of the diameters is 7, or diagonals is 7, the other diagonal is twice as much, so what's the other diagonal? So D1 is 7, so we'll call D2 14. Like that. We good with that? Watch it on the video. I got to move on. Sorry.
Are you going to finish the rest of this on
Oopsie daisy.
tonight? Are you going to finish the rest of this tonight?
I doubt it. You just have to watch the old videos. We got done most of this. I can't go over every single little thing, can I? This time it tells you the area of a circle. What's the area of a circle? Pi r squared. So the area of a circle is pi r squared. No, because pi d is the circumference of a circle. You can't. It's r squared. Okay, so it has to be pi r squared. Pi d is not the same thing as the area. And it says, what's the length of the diameter? So you're finding the radius, correct? And then you're just doubling it to get the diameter, right? So you just put a 63.6 in for the A. Solve for r. So how do you do that? Well, not yet. Divide by pi first, and then square root. So that's going to give you your radius, whatever that is. And then what do you do with that? Multiply by 2. Or you can just do all that in one shot. And then whatever that is, that's the length of the diameter. We good with that? Look at this.
Oh, these are easy.
Remember this one?
Oh, I remember that.
What's the little formula for that?
20 over x. 20 over.
Why does this look all blue and that looks all white up there? That's weird. Isn't that weird? Fine, look, it's all white here, but then you come down here and this is like all bluish color. See, it's like white here and then blue here. Focus? Okay, sorry. So what do we do? Oh, I get annoyed at you complaining about my videos being long. How's that? So we're even. So, all right, how are we going to do this? We go what? Okay, 20 over 15. So I'm comparing this one to this one. Is that what we do, though? Don't we square something?
Yeah.
We square the 20 and the 15, don't we? Or we square the areas. Which one do we square? I forget now. Because this is, we'll call this x.
The 20 and 5.
No, we won't call that x. We'll call this area 2. You square the 20 and the 15, don't you?
Yes.
That's what I thought. See, you got me
Can we have that one?
missing. You'll have it during the test. So so we go 20 squared over 15 squared equals what? 500 over, we'll call it A. We'll just call it A. And we don't square that. Cross multiply. Or you could set it up a little better. You could have gone A over 500 equals 15 squared over 20 squared. That'd be a little easier. Just multiply by 500, and you put that in there. Okay? 17 is the same thing. Maybe we'll go over these last ones tomorrow, okay? Because these do take a little extra effort. We're going to go over the end of these tomorrow. We'll do 18, 19, and 20 tomorrow, and then we'll do chapter 12. I don't have it copied yet. But you can just look at your old test. Yeah. Okay.